All right, 3-2. We're going to talk about some functions and their graphs. All right, so we have a graph. That handout I gave you there is a graph that we're going to refer to. Mine is got a little color to it, just so we can refer to different things. And so you've got a X and Y axis. You've got the blue line is a graph. That's an oscillating function. It's either a sine or a cosine function, depending on what it was. Doesn't necessarily matter what function it is. The idea we're going to be dealing with is answering questions about a graph out of that. And I use this one because the numbers are different, and it makes you have to look at it a little closer, which is what you need to do when you get one that has just regular numbers on it, is look at it closely and make sure you're reading things correctly out of that. So we're going to answer some questions about this graph. So I'm going to be kind of flipping back and forth between our questions and the graph. So the first question we're going to ask is, what is f of 0 in that graph? So you've got your graph in front of you. What is f of 0 for that function? 0, 4. So f of 0 means find the y value when x is 0. So the answer to that would be 4. So you go to that ordered pair there, and the answer is 4. It's really basic and easy thing. Maybe they ask for f of 3 pi over 2. 3 pi over 2. 0. So 3 pi over 2. This is pi over 2. There's pi. There's 3 pi over 2, or 1.5 pi, which is that. So the y value for that is 0. So when they ask you for a function value, they're asking you for the y value out of that. We kind of talked about that a little bit yesterday, or the last couple of days with the first section. Same idea, but we're relating to a graph instead of to an equation. We don't know the equation for this one. Could be multiple ones that would fit it. But we are relating to a graph instead. All right, so let's kind of relate again to our previous section. The domain of that particular graph that we're given there. So if we're looking for domain, what are we talking about? X values, absolutely. X values that work for the problem. Okay, so when we write domain, when we're talking about those things up here, we talk about what's the lowest number we start at, and then where do we go from there, or what's the highest number we get to, that sort of thing. So we look at the graph in the same way, but we got a picture to go by. So we look for points that have X values because we're talking about domain. So what is the lowest X value here? 0. And is 0 included? Yes. It's got a filled in dot there, right? What kind of symbol would be there at that point if it was not included? An open circle. Yeah, you guys remember that from Algebra 2, or maybe we did that some pre-algebra and 7th and 8th grade too with that. So an open circle would indicate not included. A filled in dot indicates included. Okay, so we look at that. We say, okay, we're going to start at 0, and we're going to go up to. So we're following the graph along. We're looking for places for numbers that might be skipped, you know, where we would do that parentheses U thing that we were doing earlier. So we're looking for holes in the graph, so empty circles. So are there any as we go through this one? No, not any on this one. Wouldn't want to muddy the waters too much here on the first one. So we have all of these X values that are on this blue line until we get to here. And that X value is 4 pi. Is it included? That's a filled in dot, so it is included. So 4 pi is the last X value. So that is the interval notation for the domain. Let's get the set notation for that. So this could be written with an inequality. A compound inequality is the method that I'm going to use, because we're going to start at 0. X's are in the middle. We're ending at 4 pi. What inequality symbols go between those two? So all the X's, as long as X is what to 0 and 4 pi? Greater than or equal to 0, because we're including it. And then what to 4 pi? Less than or equal to. So we get that going on there. So we've written our domain in interval and set notation for that. So it's all based on looking at the graph instead of dealing with an equation here is the focus of this this part of the section anyway. All right. Fourth question, let's talk about the range. We didn't talk about this much yet in the first section. So what's range? The y values, absolutely. So y values up and down. So same idea, it's just up and down instead of side to side. So what's our lowest y value? -4. What's our highest y value? +4. Are there any y values that are not included in the middle, in between those two? Any open circles? No, there aren't any. So our range goes from -4 to +4, including those. And when you write that in interval or in set notation, you use a y instead of x because it's range. And same idea, -4 less than or equal to y less than or equal to +4. How many times would y equals -2 intercept the graph? Y equals -2. Where's that represented at on my picture here? The red line. That's y equals -2. How do we know that's y equals -2? It's 2 down, and y equals the number is going to be what kind of line? Horizontal. X equals the number will be vertical. So those things won't always be drawn on the graph before you look at it. Sometimes you'll have to add that in there, but that's the idea, though, is remember, if it's y equals a number, it's a horizontal line. If it's x equals a number, it's vertical. And then they might ask you about a slope-intercept line. How many times would it intersect the graph out of that? So just keep in mind those things are possible. So when we look at that, we see that this red line intersects our blue line how many times? 4 times. Doesn't ask us to find where it intersects those. That would be a little more daunting task. It just asks us how many times. Number 6, where is f of x greater than 0? And we're going to, so greater than 0, f of x greater than 0. What does that even mean? What does f of x greater than 0 mean? What part of the graph are they talking about? The y values. It asks, where are the y values greater than 0? So where are the y values greater than 0? In a general sense. That's what we're saying. I think I'm on the right track.
0, 4, and 2, 5, 4.
Okay, those are those points are places where the y values are greater than 0. Are those the only points?
Above the
Anything that's above the x-axis, any part of the blue line that's above the x-axis is going to be a place where that's happening. So we've got lots of places. Is it possible to list all the ordered pairs that are on this part of that line? No. Not there. You could list a bunch of them, but you couldn't list all of them because it's an infinite number there. That blue line just represents every single ordered pair at smaller and smaller increments, so you never can get all of them. So we need to be able to state this in some sort of way that tells us all of those ordered pairs between certain x values. Okay, so where does it start? Well, the graph starts at 0 on the x-axis, right? So that's our starting point. That's above the x-axis, and it stays above the x-axis until we get to pi over 2. All right? At pi over 2, it is above, on, or below the x-axis. On. So that means the y value is what to 0? Equal to. Our question was not equal to, it was greater than, right? So when we write that, we're going to use an interval to write that. That interval, we're going to include 0 with a bracket because 0, 4 is definitely positive on the y value, right? So it's above the x-axis. And then we go all the way up to pi over 2. Do we include pi over 2? No, because the y value for pi over 2 is 0. So it is equal to 0. So we can't include it. So what do we put there? Bracket? Parentheses. Parentheses means we're not including. So we're going to use parentheses there. Okay? So there's one interval in which the y values are greater than 0. What's another interval from our picture? So we're not going to put u here because we're not talking about domain. We're just talking about separate intervals. So I'm just putting a comma. What's the next interval where the y values are greater than 0? So I'm following the line along here. I've got to here. Once I drop past pi over 2, all of these y values in this little trough area are what? Less than 0. They're negative, right? So that we don't count those. So I'm keep following along, and I finally get here, and I get on the x-axis. So that means my y value is equal to 0 there. After that, it goes up, right? And we get to that point JC was telling us about. That definitely is a positive one. So here we're going to start at 3 pi over 2 and go to where? 2 pi? Is the y value still positive past 2 pi? Yeah, they're still positive right here. So we do go all the way back to, as long as the y values are greater than 0, you don't stop. Okay? Unless there's a hole, like an empty circle somewhere there. Okay, so we're going to go from 3 pi over 2 all the way to 5 pi over 2. Parentheses or brackets? Both of them? Both of them. The y value for both of those x values are zeros. They're not greater than 0. Okay. What's the next interval? Seven pi over 2, because after we pass 5 pi over 2, we're negative y values until we get here. We're starting at 7 pi over 2 and going to where? 4 pi. Parentheses or brackets? Parenthesis, bracket on the last one. Notice our endpoints here. We started at the lowest part of our domain and we went all the way to the highest part of our domain. When you're looking at a graph, you got to cover the whole domain when you're talking about these intervals out of that. You got to make sure you went across the entire domain to make sure you got all those intervals out of that. Okay? Not bad, not bad. Where is f of x equal to -4? A little easier problem, I think, for number 7 than it was for number 6, but still a different kind of problem. So where's that at on the graph? Say it again. Pi and 3 pi. Because it asks where's f of x equal to -4. It's asking where's y -4. Those two places. So pi and 3 pi. So x equals pi and x equals 3 pi. Both of those. More than one answer there. We're not writing that in interval notation because it's single spots, not a range of values out of there. Number 8. Let's talk about intercepts. What kind of intercepts do we have when we talk about functions? X and Y intercepts. Those are the kind of intercepts we've been finding since we were in Algebra 1, or probably 7th and 8th grade. You do X and Y intercepts for lines in that as well. So we've been doing X and Y intercepts for a long time. That's the only kind of intercepts we have when we're talking about just of a function. You can have X intercepts, you can have Y intercepts. So we need to find all of those. When it asks for intercepts, let's find the Y intercepts or intercept and the X intercepts. Okay, what's the Y intercept? 0, 4. That's easy. Ordered pair, 0, 4. And then the X intercepts, several of them. So look, pi over 2, 0. Pi over 2, 0. 5 pi over 2, 0. And 7 pi over 2, 0. So X-intercepts are where Y is 0. Y-intercepts are where X is 0. We know that. We've been knowing that for a long time since we started this algebra thing that we've been doing. Okay, so not too bad. Let's talk about a couple more intervals for this particular graph. Intervals of increase. And then number 10, we'll do intervals. We'll kind of do these together, of decrease. If a function is increasing, what direction is it going? Up and to the right. As we read it left to right, an increasing function goes up and to the right. If it's decreasing, it's going down and to the right. Think about slope. Positive slope goes up and to the right. Negative slope goes down and to the right. So interval of increase for this graph. So we're looking at that picture. Where does it start? All right, what's going on? If we just read it left to right, we'll start here at 0. What's it doing from 0 to somewhere?
May I have
So
your
from
attention,
here to
please?
here, it's doing
Anyone
what?
interested in playing tennis this year
Decreasing.
needs to do
So
Coach Harville as soon as possible. Boys soccer will be
0
today from 3:30
to
to
pi.
4:45 at the soccer field. Anyone interested in playing this
At
year
pi, what's it
can
do?
show up or contact Coach
Turns
Evans.
around, right? Starts
Those
going back up.
SFA members
So that goes
who
from
attend
pi
Ag Day
to
and
2 pi.
National, please see Mr. Lipford today or tomorrow.
And then at 2 pi, it turns around
day.
again, right? And turns around and it goes back down to 3 pi. It's decreasing from 2 pi to 3 pi. And notice I'm using parentheses here because what is at the peak or the valley, is it increasing or decreasing? It's not doing either, right? So we're using parentheses because we're not including that point on either of the intervals there. All right, so at 3 pi, it starts increasing again and increases until we get to 4 pi. And you've got the intervals of increase and decrease out of that. All right.